Thanks, Phyllis. Okay, we'll go ahead and get started with the next talk. Our next speaker is Therese East. She's going to be speaking on Lake Okeechobee interim goals. Ms. East is a supervising scientist at the South Florida Water Management District with over 25 years of experience working in lacustrine and wetland ecosystems. She conducts research and monitoring efforts on Lake Okeechobee per the Protection Program and assists with evaluation of Kissimmee chain of lakes headwater restoration projects. All righty.
Thank you, Andrea. Good afternoon, everyone. First, I'd like to thank the Interim Goals team of Zach Welch, Andy Rodusky, Chuck Hanlon, and Steve Schubert for the development of the Interim Goals and Interim Target Report on which this presentation is based. I'd also like to thank Vicki Garcia, the new Lake Okeechobee co-coordinator, for assisting with this presentation. Agnes McLean gave an excellent overview of the model scenarios earlier this afternoon, so I'm not going to go into details of the model runs. I'll just remind you, or in case you didn't see Agnes's talk, that these are the four scenarios. The 2026 and the two 2032 runs will be compared against what is considered the current existing conditions, or the ECB IGIT. And here are the critical assumptions of the data set. I'd like to point out the two that are specific to Lake Okeechobee. First, the Lake Okeechobee Watershed Project is still in the planning and development phase, so it couldn't be included here. And second, the model runs are based on the current Lake Okeechobee regulation schedule because the new Lake Okeechobee System Operating Manual is also still in the planning and development phase, so it couldn't be used in these model runs. These were the best tools available at the time, but it is important to keep these two assumptions in mind for the remainder of the talk. The Lake Okeechobee interim goals indicators used to demonstrate progress for SERP are lake stage, submerged aquatic vegetation, and emergent aquatic vegetation. Now, I want to point out that only lake stage was modeled in the way Agnes described in her earlier talk. For submerged aquatic vegetation and emergent aquatic vegetation, I'm just going to describe the interim goals since we don't have models to predict how they would be affected by these different scenarios. The lake stage indicator is measured as an ecological envelope around a seasonally fluctuating stage of between 12 feet during the summer or wet season and 16 feet during the winter or dry season, and it's represented here in orange. Now, those of you that are familiar with Lake Okeechobee operations are saying to yourself, hey, wait a minute, that's the old ecological envelope, and you're correct. Recover has recently developed a new ecological envelope and a new recovery envelope, but these revised performance measures were not completed and approved until 2020 after this modeling effort. So the 2007 performance measure was used here. The metrics that were used are the amount of time lake stage is within the envelope, the amount of time lake stage is above or below the envelope, and the amount of time lake stage is extremely high, greater than 17 feet, or extremely low, which is less than 10 feet. When lake stage is within this beneficial envelope, the water levels in the near shore and marsh are at optimal depths for plant growth and development. Recession rates are optimal for wading bird nesting and foraging, and algal bloom potential decreases. So here is an example of how lake stage is compared to the ecological envelope over time. Again, the orange area represents the envelope, Now the black line is the daily average lake stage. So lake stage is assessed relative to the ecological envelope in terms of magnitude and seasonality of fluctuations. Once again, restoration progress is evaluated by measuring the amount of time that lake stages are within the envelope or within the orange area, above and below the envelope, or extremely high, so above the top blue line, or extremely low, below the bottom blue line, with the ultimate restoration target of stage always being within the orange. And here are the model results. So the 2032 Packer scenario had the biggest impact on lake stage interim goals. For within the envelope, the percent of time increased by 4% over the current baseline conditions. It went from 28% to 32% of the time within the envelope. The amount of time stages above the envelope also increased by 2% in the 2032 Packer compared to the existing conditions, and the amount of time stages below the envelope decreased by 2%. So as you can see, the SERP projects in the 2018 integrated delivery schedule are expected to have minimal impact on Lake Okeechobee, but there are benefits to other regions and stakeholders. For instance, the 2032 Packer moves the average lake stage up by 2%, which will increase water supply. Also, in the previous talk, Phyllis outlined the benefits to the estuaries, and the talks after this are going to explain the benefits further downstream. However, Lake Okeechobee stage is expected to improve as some of the projects that are in the planning and development stage, like the Lake Okeechobee Watershed Project and the Lake Okeechobee System Operating Manual, are authorized and come online. Now let's look at submerged aquatic vegetation. The abundance of nearshore SAV is a key indicator of the lake's ecological health, as it provides essential habitat for fish and other aquatic organisms, and also competes with phytoplankton for nutrients, thereby reducing algal blooms. We have mapped the nearshore submerged aquatic vegetation since 2001, and data indicate that coverage is heavily influenced by water levels and extreme weather events. In 2016, after a review of the new SAV data and historic distributions, the interim goal was redefined. The original recover restoration goal was greater than or equal to 40,000 acres, with at least half comprised of vascular species. But under the current lake stages, much of the 100,000 acre potential habitat is too deep, so an interim goal of greater than 35,000 acres of total SAB, or equal to 35% of the total colonizable area, it was designated. And we see that during the 5-year period of 2013 to 2017, the average did not meet the target. We know that coverage of the non-vascular species is highest when summer lake stage lows are near or below the bottom of the ecological envelope. Vascular species also benefit, but they respond more slowly. When summer lake stages are above the ecological envelope, macroalgae coverage is minimal, and vascular species also decline, but it depends on the height and health of the plant beds. So SAV needs these low lake levels to offset the negative effects of high stages in order to recover. The modeling suggests that stage will be above the envelope more often and below the envelope less often So SAV may not be able to recover after high stage events. We don't have a model for emergent aquatic vegetation either, as I stated before, but we do have interim goals. Lake Okeechobee's emergent marsh consists of approximately 100,000 acres. The performance goals in terms of aerial coverage for the specific vegetation types are listed in the table on the right, and they were based on the 1973 survey of Pesnell and Brown, the early 90s surveys conducted by University of Florida, and also recent surveys that the district has conducted and they're monitoring. These targets represent a littoral mosaic with a mix of native vegetation and shallow open water. Success will be assessed by comparing the composition and distribution of the emergent aquatic vegetation from vegetation maps like the one seen on the left to these established performance measures. So in conclusion, the 2032 Packer showed stage is within the envelope 4% more often, which may not seem like much, but it is making progress towards the goal. However, stage is above the envelope 2% more often and below the envelope 2% less often, which might not bode well for submerged aquatic vegetation growth and recovery, or for native emergent aquatic vegetation and algal bloom potential. Although improvements are minimal in Lake Okeechobee, the downstream systems and other stakeholders do benefit. CERT projects currently under construction and modeled here are not intended to reduce flows into Lake Okeechobee or to improve the incoming water quality. This exercise demonstrates the importance of planned and future projects which provide an alternative destination for both lake inflows and outflows for improvements in lake stage management. For future activities, some of these are similar to what other groups or other regions have proposed. We need to update modeling to include planned and future projects along with climate change. We need to develop submerged aquatic vegetation and emergent aquatic vegetation predictive models. Finally, we need to develop system-wide performance measures and link Lake Okeechobee performance measures to the system-wide ecology. That's all I have. Thank you very much for listening.